Hello everybody, welcome back to the channel, and today we're going to be doing a very popular LeetCode question. This is LeetCode question number 1, two-sum question, very popular. As you can see, 21,000 likes here. It is an easy question under the category easy. Doesn't mean it's going to be easy, but that's the category they have it. And in LeetCode they have easy, medium, and then hard problems. But let's not pay really much attention to that. Let's just go ahead and look at the prompt, and then we can start talking about the logic and coding of the solution. So let's go ahead and read it. So it says, given an array of integers num, an integer and an integer target, return the indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so let's take a look at the example here. So we have example 1 with our input nums array of 2, 7, 11, and 15. We have a target here of 9, so we know that 2 and 7 will add up to our target of 9, because 2 plus 7, and we're going to output the indices, so the indexes of those two numbers. So we have 2 at 0, and we have 1 at 7, so that's going to equal up to 9. And it says the output because nums of 0 plus nums of 1 equal 9. Pretty self-explanatory here. We have some other examples here. 3 plus 3 is 6, and then we want to basically always get up to our target. So we have 1 and 2 will be the output because 2 plus 4 is 6. So let's go ahead and start to talk about how we're going to code this out. And I'm actually going to put up a list here and a target, an array. So this is what we have. We have our numbers 1, 2, 4, and 9. And this is going to be, so an index. So in a list or an array, in Python they're called lists, we have an index of 0. So that's the place they're at. We have an index of 1, and then we have an index of 2, and then we have, excuse me, an index of 3. So what we're going to want to use for this problem is a data structure called a hash table. So a hash table is basically allows us to, it's a data structure that implements an associative array abstract data type that maps keys to values. So we have to think about that keys to values thing that the hash table does. So it uses a hash function to compute index, which is also called hash code. But the things we want to remember that it basically allows us to map keys to values. Okay, so we're going to be using a hash table. So I'm going to go ahead and start coding this out. So this is what we call this hash table. And in Python, it's very simple. That's how you create one. So created hash table. All right. And then the next thing I'm going to use for this problem is a function called enumerate. And this is going to allow us to get the index and the number of in our list. Allow us the index and number. So to do that, we use a for loop. So for index number right here in, and we're going to do in enumerate nums, because that is the name of our list that we're given. I'm going to create a variable called want, and that's going to equal our target that we're given minus the current number that we're at in our iteration. So for instance, let's go ahead and take a look at this. So this is pretty much what a hash table is going to look like as we go through this. Actually, just do it like this. So this is our hash table. So we're going to go ahead and we're going to start saying what is want, right? Say question mark, and then we're going to say our target is 13, and then the number is 1. So the first thing that's going to go in our hash table is really going to be 1 and 0, because that's just holding the place for us. And I'll show you why that does that, because we're going to check if want is in our hash table. And if want is, we're going to want to make our left index equal to our hash table want. All right. And then we're just going to simply return left index else. We're just going to simply use our hash table number equals index last. I'm going to return an empty list. Okay, so let's go ahead. We're going to talk about this. I'm going to slow it down and go through each line of code and what is going on. So we're using enumerate. This is going to allow us to get the index and a number. So if want is not in a hash table, we just simply add it, right? We just simply add it because we're going to be adding every single a number in our hash table. So let's go on to the next one. So that was at index 0. So let's see what's going to be at index 1. So at index 1, we're going to just simply have 2. That's going to be 1, because if we do this right here, we're going to have 13 minus the number 2, right? And that's basically, that's going to give us 12, and that's going to give us 11. And if we continue to go, we're going to do 13, right? Minus 4. And what this is due in here, this is going to put 4, and it's going to put 2 because we're at index 2, and this is going to give us 9 is what we're going to want here, right? We're going to want 9. And, in here, let's see, we're going to want 12. In here, we're going to want 11. So we have that going on. So basically what this is doing is we have our target and our number, and this is what is becoming our want. 12, 11, and 9. This is the numbers that we want. So when we're here at index 2 and we're at the 4, we're going to go to the next iteration, which will be at index 3, and that's going to give us 9. And if want is in our hash table, we're just going to make the left index the hash table of want, right? And we know, watch, I'm going to run this, and we know that's going to be at, it doesn't matter how you return it, it says it could be returned in any order, 2 or 3. Right, and it's going to be 2 or 3. So we're going to put the left index, it's going to be the hash table of want. And then we're going to return just the index wherever we're at. And we know that that's going to be 3, right? Because we're here, right? So we want 2. What we want is 9. And then we're going to return that index, which is going to be at index 3. If not else, we're just going to continue to put whatever iteration we're at in our hash table, like we've been doing here with 1, right? And then we just return an empty list, basically if there's no solution. But this one says it'll be exactly 1 solution. So let me submit this. And it's 56 milliseconds faster than 22% of the online Python 3 submissions. Sometimes when you submit it, it goes up. See, this is 63% now faster. But let's talk a little bit about the time complexity of the solution. So it's O of n because we traverse the list n elements. And if you want to talk about each lookup time in the table, as we go through this task table, is O of 1 time. But the time complexity is going to be O of n, worst case, right? And then our space complexity of O of n, because we need extra space required, depends on the item stored in the hash table, which stores at most n elements, and this is our n element. So time complexity is going to be O of n, and space complexity is going to be O of n as well. So I hope this was helpful. If you have any questions or you want to talk about the solution, feel free to comment down below. Thank you guys so much.